Okay, so all this stuff I'm just going to get rid of. Although, now that I think about it, why don't I go ahead and just save this? Just in case anyone decides they want it later on. Okay, so I've got a new SQL tab open up here. I'm going to clear this log field out again, so we're getting started. And I'm going to get rid of fave foods, and I'm going to say use AP. So we're back to our friend invoices and vendors and general ledger accounts and all that good stuff. So let me go ahead and just do the syntax like we did before for the basic select query. So to join syntax. And this is where you start off the same way as before, if you can manage it. There we go. And this time we're accessing multiple tables, right? So it's from table like before, but this time we're going to call it table 1, and we'll do a join. Table 2. Now, as you guys know, for the full verbose way of doing it, you put in an inner join here, right, if you're doing an inner join. But you don't actually need to. So I'll just leave it at the simplest syntax here. And then, generally speaking, what you want to do is indent for the on clause, as you saw me do in the previous recording or the previous demo. And then condition, it can be more than one condition. You can actually join together more than one table, or rather more than 2 tables. And the way you do that, as soon as I do that, I want to start outdenting some of this stuff. But join table 2, if you're going to join it to yet another table, then you do it down here, join table 3, and that will have other conditions, or just condition, whatever it is, like so. And then you can put your other stuff down at the end of it, like order by, or where clauses, or limit clauses, or that sort of thing. So that's basically how it looks. So let's go ahead and take a look at some simple queries. Let's see how far we get here. I want to give you as much as I can because, again, the questions at the end of this chapter, a couple of them are a bit scary. So I'm going to do a select, and this example uses a lot of the same ones as the last chapter. So I'm going to do this select vendor name. This time I'm going to be pulling from 2 different tables, which it didn't do before. So before, when it selected something from vendors, it would select other stuff from vendors, like vendor ID, vendor name, vendor zip code, stuff like that. Now, for the first time, we can grab from multiple tables. So I'm going to grab vendor name from vendors and also grab invoice number from invoices, because that's not in the vendors table. And let's say invoice total. So the total amount of the bill. And I'm going to do from vendors. That's going to be my left-hand table, because that's where I'm pulling the original select. But then I'm also going to do a join. That's with an N. Invoices. Now, if I do it, remember, if you do without the conditional clause, the on, it's going to give you a huge, like, let's see, I'm just going to go ahead and do it. Control Enter. And yeah, it returned almost 14,000 rows down here, which is crazy. Each of these tables, like one of them is, I think, 122, and the other one's 114, something like that. So basically, it's matching everything with everything here. I think that's what it's doing. What I'm going to do later on is I'm going to run a cross join using this exact same query and see if it comes up with exactly that number of rows. And if it does, then I'll be pretty sure it's doing the same thing. I won't do that right now. So anyway, let's do our on condition. So on, now you guys probably already know what's going to happen here, right? I think we talked about it before. Let's do a quick, simple select on both of these. Select all from vendors. And I'm also going to do a select all, I really shouldn't try to type this fast on this little laptop, from invoices. Invoice. There we go. Okay, so let me run these one at a time. And this is all of the columns here, and we can see that at the beginning there is this vendor ID, and this is the one I'm going to be nailing. Let's go to invoices and check that one. And yes, there's a vendor ID. It's not the primary key over here, but it's got one of these over here. So let's take a look and we'll run these together. So I'm going to do join invoices on vendors dot vendor ID equals invoices dot vendor ID. Okay, so it's saying that look for places where these match, where you've got a number in vendor ID on vendors. Look for that same number on vendor ID on invoices, and if you can find a match, bring me that row, bring me that return. So let's go ahead and check it here. I'm going to do Control Enter now, and we get a much smaller number of these. Basically, in this case, an inner join is going to return all of the second table because the first table is larger than it, right? And everything in table, well, here, let me back that up. Stop the wheels here. Let's take a look at the results. First of all, you can see, look at all these, like the repeats of all the Federal Express Corporation here, and there's other ones that are going to, it's like it keeps showing up over and over again. There's more FedEx, and there's some other ones that have some repeats too. We could do like a select distinct in order to see where they are, but there's a bunch of them. So this will tell you right here why vendor name is not included in invoices, right? Why vendor name and invoice number and invoice total are not kept in the same table is because you get this kind of redundancy in the table. When you're building a table, I'm jumping ahead of myself. When you're building a table, you don't want to do that. You want to practice being as dry as possible and not go for this repetition. So if instead you can supply each vendor with a vendor ID that you can put in both of those tables, then this verbose bit about their actual English vendor name, you only have to have in one table and you match them up with the IDs. That's the idea. So that's why you have these in different tables, is to keep your code, or you keep your data in this case, dry. So what kind of relationship is this? This is a one-to-many relationship, and you can see it expressed right here. One-to-many in this case means there'll be one from vendors and many in invoices. What that means is that each one vendor can have one invoice or many invoices, that's the one-to-many, or no invoices. So Federal Express has many invoices here, right? That's the one-to-many, and that's why you're getting the redundancy in the results. Maybe UPS only has the one, and there are certainly other vendors that don't have any. So that's what one-to-many means. For each one entry in one table, there are 1, 0, or many entries in the other table that correspond with that, in this case, the vendor ID. If you look at it from the other direction, from invoices, you could say that each entry in invoices is going to correspond to only one entry in vendors, right? An invoice can't belong to two different vendors at the same time. It has to belong to only one. So that's kind of the one-to-many relationship. That's what that's describing, and I think that it starts to click, I hope, when you start to see results like this. And, oh yeah, that really is like one that corresponds to many different invoices here. Okay, so let's start simplifying this a little bit. What I really meant to do is actually maybe I did, start out with the inner join. But again, one way to simplify that is just to do join. If you like it the other way, there are some people who prefer to code verbosely and make things as explicit as possible, and I won't argue against that. I tend to go for, saving some finger fatigue myself and try to do things as short and sweet as possible, usually. Let's simplify a little bit further here. So notice that I had to repeat things here. I had to repeat vendors here, from vendors, and then tell it, yeah, I want you to match up the vendor ID from vendors, and then match up vendor ID from invoices, which is here. So I had to repeat myself a little bit. You can reduce that a little bit by using table aliases. And an alias is just a new identifier for the table. And it makes it super easy to do. If you're in a procedural language, you would probably have to create a new variable and then assign it and all this stuff. In this kind of declarative language, all you have to do is hit like where these tables are referenced the first time, like the from and join. Put the cursor right at the end of the first identifier, vendors, hit the space bar, and then type in what you want the new identifier to be. So V, let's say. I think V is easier to type than vendors. And maybe I'm going to have to do a lot, right? And then if I do that, down here, I don't have to type vendors.vendor_ID. All I have to do is type v.vendor_ID. I can do the same thing here for invoices, spacebar, and then my new identifier, which is much simpler to type. And then down here, all I have to do is do i.vendor_ID. And as you can see, when I run it, works just the same. No problemo. Now, something you have to watch out for with table aliases is that once you specify an alias up here, you have to use it. You cannot go back and use the original table name. Let's try it out. I'm going to hit Control Z here so that I've still, and maybe I forgot that I did it up here. I forgot that I did these aliases. Oh yeah, I want to pull from invoices, what have you. You return enter or Control Enter, and bam, getting an error message, and it's saying unknown column. Vendor ID doesn't exist in that database. Wait, of course it does. It's right here. But no, it's because it's now thinking about it this way. So that's what you have to do. Now you can do, you don't have to specify aliases for everything if you don't want to. Let's say you get really sick of typing vendors, but you don't mind typing invoices. It doesn't come up that much. So you can just do that if you want to. That's perfectly fine. And that'll get rid of the error message. So yeah, you can do aliases for everything, or you can do aliases for some things, or you can do aliases for none of them. It all works fine as long as they continue to match. Something cool about doing these aliases, as you will discover, either we'll do it in demo here or else you'll find out in the chapter when you do that, is that these new alias identifiers are hoisted to the top of the statement. Does anybody know what I mean by hoisted? Anybody here use JavaScript before? JavaScript, if you declare variables or just declare global scope functions, they are hoisted to the top of the script, which means that even if you declare them at the very end, they are usable at the very beginning of your script, which can lead to a lot of confusion, but can also be really helpful sometimes. And they introduced the let keyword more recently, about 7 or 8 years ago. One of the main things it was meant to address was that, along with function scope and all that. But this guy right here, like there's no need for it right now. But let's say that I did, let's go ahead and change this so that I do need it. Let's say instead of vendor name, I want to introduce a vendor ID. Okay, so I want to return a vendor ID instead of a vendor name like this. And it's giving me an error code down here. And it's saying, I don't know if you can read this down here, but it says that it's ambiguous. And it's saying that because there's a vendor ID in both tables, and it wants me to tell it, well, okay, which one of these do you want me to pull it from? Now, with the results, it's going to be the same thing either way, right? But it still needs to be told. So check it out. If I want it to be from vendors, I can just do this, even though I don't declare the new identifier until the very next line afterwards. It still works. It gets hoisted to the top. So that's handy to know. In fact, it's going to be critical to know because, as you know, once you declare an alias, you got to use it. So even though this is in line 1, and I haven't declared this yet, I can't use that up there because it can't find it. So it's kind of fun. I think it's fun and handy. So there we go. We've got table aliases, and I'm using only one of them, which you can, but once having used it, I have to use it everywhere within that statement. After that statement, starting a new statement, I can do basically starting over from scratch. Okay, so let's see. With these, you can filter this based on something that is being returned in the table down here. So for instance, I could say order by invoice total descending. You guys learned how to do that in the last, the chapter 3 that you're currently working on. and that'll do it. That'll order it by, largest invoice total down to bottom. But you don't have to order by a column that's being returned here. You could use a column that's not even part of the result set in order to order this. So I'm grabbing vendor ID, invoice number, and invoice total. Let's say I want to order this by invoice date. No problem. It'll do it for me. It's not showing me the invoice date, but it is behind the scenes. It's ordering these based on the invoice date that it's pulling from one of the tables. In this case, it's pulling from the invoices table. Remember that if the column name is not ambiguous, I don't have to specify what table it's from. It already knows, yeah, there's an invoice date in invoices and there isn't one in vendors, so that's going to be fine. I'll just grab it from that. So yeah, it can order from that, even though it's not part of the results set or the result grid. And I'm mentioning that in particular because there are going to be some times when that doesn't work, where you actually do have to specify what table it's from. And I think I'm thinking of, no, it's not, is that the, I can't remember if it's the union or something else. Anyway, we'll find out. I've got it in my notes here as we go forward. Okay, let's see, blah, 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 we did that, how to join a table in another database. Let's go ahead and do that one. Okay, so I want to do, I want to select vendors. No, let's see, that's not what I want to do. Hang on just a second here. I knew my notes weren't going to make any sense. Well, let's go ahead and use this here. I'm going to do the invoice number and the invoice total again because that is going to be, what was it, vendor? I'm going to go back to vendor name, I think. And then invoice, what was it? Invoice number, and invoice total. But there's another table that has this stuff in it, the invoice number and invoice total. If we look down into, I think it's the EX database down here. Let's see if I'm right about that. Tables, and there is one called active invoices, another one for paid invoices. Let's look at our active invoices. Not color sample, but come on. Okay, yeah, so this also has an invoice number and an invoice total. Okay, good, we'll use that. So basically, it's the same naming of columns, except that instead of grabbing from two tables that are in the same database, which is AP, we're going to grabbing this from vendor, which is, vendors, which is an AP, and then these guys we're going to grab from active invoices, which is an EX, a completely different database. And we don't have to use the use keyword in order to get it either. We'll use the dot syntax, just like we use the dot syntax to grab like columns within a table. We'll be using the same thing to grab tables within a schema. So easy peasy. So I'm going to do from vendors, and we will do a join. And I want to get active invoices here. But again, if I do this, let's see, I have a vendor ID too, good. So let's go ahead and try it like this. So on, just like the one upstairs, we'll do, actually, since we started using the aliases, let's go ahead and do it. So vendors V, so V is my new one for vendors, and then active invoices I'll call AI. So on v.vendor ID equals AI.vendor ID. Right, so, and I might think, okay, cool, I'm just off to the races now. I'm sailing free and everything's looking good, and I'm getting an error message. Oh my goodness, active invoices doesn't exist within AP, so no problem. Join EX, which is that other database, dot active invoices, followed by the alias. Control Enter, and now it's working. So I'm getting the invoice number and total from active invoices within a completely different database by using this EX. Oddly, I think you can also do this me try that again. ex.ai, vendor ID, and I believe this will still work. Yeah, it still will. So it's like once you've done this for the duration of this code block, it knows that AI is part of EX. You don't have to use the EX here, but you can, and it still accepts that as being the name of that active invoices table inside of EX. So anyway, that's just kind of an experiment that I was doing. It worked out, but normally you don't have to do that. You don't have to worry about it. Okay, so that is joining a table in another database. How are you guys doing with this stuff, by the way? Do you want me to stop or pause or like do any of these over again or explain anything that I've done a little bit better or a little bit different? Please don't be shy. Please interrupt me anytime with a question.
I think I'm good so far.
Okay, excellent. Thank you. Do let me know, though. That goes for all of you. Okay, so let's see. I'm kind of going through the chapter examples, some of which have been simplified a little bit. And some of these we can skip past because we were doing them with the Fave Foods example, or whatever it was called. We joined a table in another database. That's going to be, oh yeah, okay, compound join conditions. So yeah, you'll need to know this. So you can do more than one condition. This guy being the condition here, right? The on check if vendor ID equals this vendor ID and then return those results. But you can have multiples of those. So let's see, if I go back to the example that I planned to use for all this, I'm going to do select vendor name, invoice number, and invoice total from vendors, my left table, and join invoices, and let's do some aliases. B and I. There we go. So this is nothing new here, right? We're just lining up the vendor IDs on the two tables. This is just exactly what we started with up there. But I don't have to stop here. I can do other conditions before the semicolon closes by using the AND clause. Just an AND operator here. And then I can specify some other condition here. And now this could also be comparing two different columns or more different columns. It could be running arithmetic expression, you know, like the one that we've already seen, which gets used a lot in this book, which is the invoice total minus payment total minus credit total. Use that in some kind of condition. If I just, let's say I just want to grab all the invoice totals that are less than $500. Okay, that's about as simple as it gets, but you can see that there are two different conditions. And so what that's going to be is it's going to be further filtering the results. So this will get you a certain number of results, which would be, I think, the 114, and this should reduce it further. I don't know what it'll come out to exactly, but yeah, 39 rows. So it's a smaller amount than the 111. And if you go scroll through these, you can see that these are all going to be, oh, I did greater than $500, didn't I? Let's do less than $500. That's what I said. All right. I was looking down here going, wait a minute, that's not happening. Okay, less than $500. Now these are all less than $500, and I got 75 rows. Okay, so that is multiple conditions on a join there. Okay, let's see. A self-join, I've got an interesting example of that one that I actually think is a little bit better than the textbook example, but I'm going to wait because it's a little bit crazy. We'll come back there if I feel like we've got a shot. I want to wrap up around 7:30 if I can. So if we have time, I'll get back to it. Let's see. We still got to join. Did we join more than one table up here already? No, we did not. Or more than two, I mean. Let's join three different tables together. So there's an example that joins the vendors. So it's getting the vendor name from, let's see, I'm down here at EX still. Let's get up there. Okay, so vendors has the vendor name in it. Some of the other ones have vendor ID, but not vendor name. And I want the vendor name, so I got to use this one. And then on invoices, I will get the invoice date, and then invoice line items, where it talks about the individual items within each one. And we will get the line item description from here, or maybe the line item amount. That's what we'll do. So let's take a look at what that looks like. So we'll start out the same way. It's going to be select vendor name, which is the one I'm going to get from vendors, and then the was it the invoice? Did we say total? Let's do the invoice date and the line item amount. So these are three columns in three completely different tables, right? So I'm going to have to do two joins in order to get these guys all together. And that means that we got to find a column in common between vendor name and invoice date. We already know what that's going to be. It's going to be vendor ID, right? But then we also need to find a column in common between invoice date and line item amount. So let's take a quick look over here. The invoices down here. Now let's look at the shorter one first. This one doesn't have as much stuff in it. Line item amount is what we want to return, but look at the very top of this list here under the columns. There's something called invoice ID. I bet there's one of those in invoices too. And yep, there it is right up at the top. So in the same way that vendor ID in invoices is kind of dependent on vendor ID in vendors, same relationship here. This is a one-to-many relationship where the invoice ID here is dependent on the invoice ID in invoices. So anyway, that was an aside. Let's go ahead and get these guys joined up. So start with from vendors. That's going to be my leftmost. Now we're going to have three different tables. This is going to be the leftmost one. And let's do definitely do aliases here. That'll definitely make things easier. So we'll do our first join. Then invoices I. Now when I was first starting, I wanted to immediately go in and start doing more joins down here, but that's not the way it works. You have to do the condition for each one separately and do the first, which makes sense. So on, we already know this one, v.vendor ID equals I.vendor ID. And then underneath that, we're going to keep going and we're going to do the other join. Just kind of tack it right on the end there. So join, and then invoice line items, which I guarantee you're going to get tired of typing that one if you have to do it a lot. Definitely use the alias. If it were me, just for consistency, I would actually use ILI, just because I like things to be like crazy over the top consistent so that I always know what I've named stuff. But textbook calls it LI, so I'm going to do that too. So join invoice line items LI. And then we got to tell it just like we did up here, where we matched up the columns in these two. Now we got to match up the columns in these two. So we will go ahead and do on I dot, what was it, invoice ID, right? Instead of vendor ID equals LI dot invoice ID. And that, my friends, is how you, I almost said merge, how you join together three different tables: vendors, invoices, invoice line items. I'll hit Control Enter. Now we'll get those three columns getting pulled from three tables. Guess what? You can just keep going with this. I don't know that there's another one that's dependent on invoice line items or not. Probably not, actually. But if there were, I mean, you could easily get a schema situation where you've got tables dependent on other tables, and it just kind of keeps going from there. Especially when you start dealing with user accounts and stuff like that, it gets crazy. So yeah, theoretically, you could keep going here as long as you needed to. Okay, the inner joins implicit syntax, we already did that in the fave foods thing. Let's go ahead and do an outer join. It's going to be crucial that we get at least one of those in there. And yeah, we already did using, we did a natural join, we did a cross join, so I think that's the important stuff. Oh, and I have to do at least one union. Okay, cool. So we'll do an outer join and we'll do a union, and that'll probably be it for today as far as the demos go. Although I can certainly help you guys individually in that, of course. So working with outer join, just once again recall that it's going to be grabbing all the data from one table unless it's been, filtered or limited in some way. And then wherever those fields do not match a corresponding field in the other table, we'll get null values. So I don't know, let's go ahead and do the same thing we've been doing. Why not? We'll start with that at least. So I'll go ahead and do that same select vendor name, invoice number, I think it was, and invoice total from our left field. And this is going to be, for the first time, actually the left table. If you're talking about inner joins, then it doesn't actually make sense to talk about those. But outer join, it does. Yeah, vendors is now going to absolutely be the left table in this to make a left join. Okay, so from vendors, and then let's do a join. But this time, remember, we can't just do a join. If we just do this, it's going to think, oh yeah, we're talking about an inner join. So let's do the full syntax first. I'm going to do a left outer join like this. And then note that you don't actually need the word outer. If you've got left or right here, then MySQL understands that you're talking about an outer join there. So we'll do left join invoices. Oh yeah, let's go ahead and do the aliases again. v.vendor_id equals i.vendor_id. I hope you guys don't get bored watching me type the same thing over and over again, but I'm hoping that that kind of helps with, kind of internalizing. If you see me do the same thing over and over again, that we'll kind of internalize it a bit. So anyway, let's go ahead and try this. So we got from vendors v, left join invoices I on v.vendor_id equals i.vendor_id. Go ahead and click enter here, and take a look at this. So it's returning, wow, it's returning 202 rows. It's actually getting more than either one of the tables by itself. And well, we'll get into that stuff later, database design, right? But the results, it can happen sometimes when you're getting that. Remember that there are certain ways in which redundancy is reduced in these two tables, like not having vendor name in invoices and other tables and so on. And sometimes that means that the data that you retrieve from more than one table can start ballooning out, even when you've got a condition set like this. But here's the important thing. So this first one comes from my left table, vendors, and this is all of the values in there. And then wherever those values do not have a corresponding value in invoices, we're getting null values there. Wherever it does have corresponding data, it's going ahead and putting that in. Oh yeah, I found whatever is the vendor ID for Abbey office furnishings in invoices, so I'll give you the data there. But for American Booksellers Association, they didn't have any invoices, so I don't have any data from that table to give you, so I'm just going to give you null values for that. And as you can see, there's quite a few null values if we go on down here. Now, if we switch these guys around, actually, if we switch them around, I don't expect that we would have any null values because invoices is a smaller table than vendors, and also we already know that the vendor ID is always going to correspond to one vendor ID in vendors. So if we move these around, let's go ahead and try it. I'm going to copy and paste this and just switch the tables around here. But when we run this, I'm not expecting to see any null values here. So instead of vendors V, I will start with invoices I up here and do vendors V down here. Oops. And try it out. So we're getting something that looks similar, but it's a smaller table, right? 114, which is the same length as the smaller of the two tables, which is now the left table. And as a result of the relationship between these, the one-to-many, we're not getting any null values anywhere, actually. Just not happening. Okay, so that is just a couple of those for outer joins, and then the one more thing that I gotta make sure I show you, which we did do with the Fave Foods, but still, we got to do this with an example from the textbook too. And this is going to be a union, which again, it's kind of bizarre when you first see it. When you first try to do one, it feels weird to do it this way. But it's another way of getting data from two tables that actually is not it's not a join at all. It's a whole different way of doing it. A join still has one select instead, unless you've got subqueries going on, which we'll learn about later. But in a union, you have two different select queries. You select one table, you select the other table, and then you create a union between them. So let's go ahead and do that. And as you guys know, I kind of like to go down and type in the union right off the bat because it's outdented. And then, arrow up and then tab in and do the first select statement here. So let's say here, I'm going to do something a little bit more complex than what we did for the Fave Foods thing, where all we were doing is doing a select all here. But this is one thing that unions is really handy at, is merging stuff into the same column by using a column alias. If you remember what a column alias is where you rename the new column as something else. So like when we did the invoice total minus payment total minus credit total, and then used the as keyword and created a new name for that results column so that it wouldn't just be named the expression name. You can use the union in order to combine stuff from two different tables into the same column by using the same alias name. So let me show you what the heck I'm talking about here. I'm going to get invoice number, invoice total, and let's see, do I want the invoice date? Yeah, I want the invoice date too. I'll do them in this order. Let me zoom out just a little bit. That's in, there's out. And let's go ahead and call this, no, let's see, I want to do something else. I'm going to have to open this up. Sorry about that, because it gets a little bit crazy looking, but let me split this up onto different lines here. Sorry about that. Let's do it. Okay, invoice total, and then I'm actually going to put in balance due as, and then just come up with a name for the column, like payment status. Let's call it payment status. Like that. Okay, so what I'm doing is I'm grabbing invoice number, date, and total, balance due as payment status, and the tables that I'm going to be using here are from, let's see, are these from, yeah, these are from X. We just used them, didn't we? Hang on a second. Hang on. Okay, here's the EX and the tables, and notice that down here we have got, let's see, active invoices here and paid invoices down here. And these tables look very similar in structure to each other. They've just got different data in them. One of them's got, invoices that are still active and have not been paid. And then the other ones have paid invoices, like invoices that are in the history books, right? They've already been paid. So those are the two tables that we're going to be bringing together with this union. Let's see if I can pull this down a little bit. Nope. A little bit here. Okay, there we go. So what I'm going to be doing is I'm pulling these guys from, and this is the balance due, right? This is the ones that still owe us money, so I'm going to be pulling from active invoices. Those are the invoices that haven't been closed yet. And I'm going to have to specify the database name here too. I could use EX, but I don't want to. I'm going to do EX.active invoices. Now, I'm not going to bother with using aliases here. This is not a join again. These are two completely different select statements. They are going to look a lot alike, so I am going to be able to take this and copy it and put it downstairs here as well. So I'm going to copy all that stuff, not including the union statement. Go to the end of the union statement and paste, so I've got something that right now is exactly the same thing. But this time, instead of pulling from active invoices, I'm going to pull from the other table. I'm going to pull from paid invoices. And I'm going to change the text here. You guys are going to see this is cool. This is cool. So instead of balance due, it's going to be paid in full or something like that. Huzzah. As payment status. Now notice this column alias is the same in both of these. And let me just make sure I'm not forgetting anything. Yeah, should be fine. So basically, wherever we get a row from the active invoices underneath the payment status, I'm expecting to see balance due. And then whenever we're pulling something from the paid invoices, the payment status column will say paid in full instead of balance due. Let's try it. I'm going to put a semicolon here and hit Control Enter and see if I managed to do everything right here. Let me pull this up a little bit more. So we were seeing a lot of invoice information here with a lot of balance due. That's the stuff from active invoices. But let me scroll down a bit here, if it lets me. And at some point I'm expecting to see paid in full down here. And these are all the ones that have been pulled from the paid invoices here. Notice the cool thing here, it's in the same column, right? So this is how you could start to earmark certain pieces of data pulling from different tables. Some of them as being, in this case, balance due versus paid in full. Now I could also go in at the end of this union and do an order by. And let's try something here. I'm going to try order by invoice date, like so. Okay, hit Control Enter, and looks like it worked. So I actually didn't even need to specify which table I want to pull this from, because it's pulling from invoice date here, right? It's pulling from one of the results columns. Now let's say I grab something else, like, let's see, what am I not using? Oh, let's use vendor ID, right? We're not using vendor ID here. Let's try order by vendor ID. Control Enter, and whoops, I've hidden the stuff down here so you can't see it. But, so I'm trying to show everything on this tiny screen here. But yeah, the action panel is now hopelessly hidden down here. But I am getting an error mess. Oh, there it is, yeah. Unknown column, vendor ID, and order clause. So you might think, well, okay, I know how to fix that. I'm going to use an alias here. It actually doesn't work. This is one of those cases doing a union that, as far as I know, you pretty much have to order by something that's being returned here. So hence, ordering by the invoice date worked because that was in one of the results, in the results alias column. But you cannot, unlike a simple inner join or outer join where you can order by something that's not being returned, in this case it has to be something returned, as far as I know. Okay, I've gone over what I intended to do by about 6 minutes, so even though there's still a couple of things I'd like to show you in addition to this, especially doing a self-join, because that's, to me, is like one of the mind benders, is when you start to use inner join, but you specify the same table for both of the tables that you're joining together. And you won't need to use that very often. But there is an example of it in the textbook, and I believe in the exercises it will ask you to do that as well. So just be aware that, okay, I better do it here, just real quick. So this is called a self-join. Sorry, this will only take a minute though. I'll just show it to you. We won't spend a lot of time talking about it. Once I'm done showing it to you, then I'll send you on a much needed break, but I think you need to see it once at least. So I'm going to do a select, and let's see, what was my example? I created an example that I liked better than the textbook example. And it uses, let's see, out of the EX, and which, it wasn't paid, it was employees. Well, yeah, it was employees here. And the reason why I'm using employees is because it's one of the tables that kind of references itself. I won't open up, the table right now so we can look at it. It's actually a pretty small table. But basically, you've got like 9 or 10 employees, and each one of the employees, except for one, has a manager, a supervisor, right? And presumably the one who doesn't is the big boss, the head honcho, the owner or whatever, right? But all these other guys have a manager, and the manager ID is referencing the employee ID column. So like the employee with the employee, or the employee with the employee ID number 8, for instance, their manager is the employee with the employee ID 3 or something like that. So that's why this is a case where you might actually need to use a self-join, and it would be difficult to do it any other way except maybe with a subquery. So anyway, this was the example. And I'm going to do it. It gets crazy because it doesn't make much sense without actually throwing in some concatenations as well. So let me go ahead and get the structure of it first. The structure of it, when you're selecting, and I know I haven't put in the select columns yet, but you're selecting from ex.employees, and normally you would call this E, and then you would do like a join and select some other table within EX or somewhere else. But in this case, you're going to be doing it, they're going to be both the same thing. Okay, so you're pulling from this one table and joining it to itself. So I'm going to call this one E1, and I'm going to call this one E2. Not E1, but E2. There we go. And the on, in this case, again, don't need to understand all this stuff. Just see it in action here. It winds up being E1 dot manager ID, which again is this guy down here, equals E2 dot employee ID. So in order to do this, in order to get the table to reference itself in two different columns here, you have to create, it's like creating two instances of the table here temporarily and having them reference each other. So it comes out to being a concat, and this part's not difficult. You guys have done this. It's just kind of seeing it all together might be a little bit crazy. Let's see, we've got E1 dot last name, and this whole bit, and then E1 dot first name. Is that the way? No, they have underscores, sorry. Like that. As employee. Come on now. Comma. And then another concat. And this one's going to be E2 dot last name. I always forget the commas in here. Don't forget that one, Bispo. Okay. And then E2 dot first name. And we'll call this one something different, like reports to, or something like that. Okay, and so you'll see the structure here. Let's go ahead and select the rows on employees first. So this is what I'm talking about. So the employee ID, and there are not very many of them, 9 of them, but the manager ID, this one is actually referring back to the employee ID instead of them being in different tables, like with a foreign key and a primary key and so on. It's just code with within the same table, as you would expect for such a small amount of data. So Elmer Jones, nice name, is employee number 2. Elmer Jones's supervisor, manager, is the employee with the employee ID of 1, which is Cindy Smith, right? So Cindy Smith is Elmer Jones's boss directly. That's how these numbers work, and that's how you got like a self-referencing table in here, which is why this exact situation where you might need to do a self-join that also references the same table with these two different instances. Let's see if I did everything right here. And it looks like it. So if I look back at the table, I would expect to see that Polo Locario and Elmer Jones both report directly to Cindy Smith. And let's see, anybody else? No, those are the only two. And so I go over here and check it out. So manager ID 1, there's Elmer Jones, and then, yeah, Polo's manager is number 1 as well. So anyway, crazy, right? Let me pull this down again so maybe you can see it a little bit better again. And I'll scroll out. There we go. So that is where you're joining the table to itself, basically in a self join. Gets a little bit weird, but again, you will see that in the chapter, and I think in the chapter exercises as well. Okay, so hopefully that wasn't too crazy or too much stuff. Any questions about anything before I stop this recording? All right, very good then. I will stop the recording. You guys go ahead and take yourselves on a break. Come back in 10 or 15 minutes. I will get this video crunched up onto YouTube. And when you guys come back, I'll come around in lab and just like last time and see if I can help you guys out with anything. Okay. All right. See you guys in 15.